Hi, we will talk about interference of wave today. So wave can have interference due to the two waves, they happen to be in the same space during the same time. So sometimes they add together, sometimes they subtract each other. And we will talk about this using the superposition principle. Interference of waves. So in Chinese, it's called 干涉 interference. So we showed one example of destructive interference. So let's say we have one wave that going from left to right with an amplitude like that. And the other wave is going from right to left and with a wave shape like that. So when they approach each other, at some point, they just assume that this magnitude, this here are identical. So when they are overlapping, and also this width are identical. When they overlap, then it looks like there's nothing there, but actually both waveforms are there at this moment. And then sometimes later, this wave is continue to travel to the left, and this wave will continue to travel to the right, like nothing has happened. But when they actually overlap, you will see that you need to add them together. And since one is positive, one's negative, they will cancel each other out. So they cancel out right here. But they don't just go away. The energy is still there, and they will continue sometimes later. Constructive interference. So if we have a wave with a waveform like this, so it's going to the right, and then another wave that's with another similar waveform that's going to the left. So as they go approach each other, when they overlap, this amplitude, let's say this is A, and this amplitude is also A, and they have the same kind of shape, although they don't look the same. When they overlap each other, then this will become 2A. And so this, it's been added together, and this is subtraction here. So this is of addition. So once they pass each other, they will continue to go their own way, and this wave will continue going to the left, and this wave will continue going to the right. So this is quite different from matter. So when you have two balls, if they hit each other, then they can bounce back, or they can go sideways, but they don't just keep going, and they just overlap in the middle. And once they finish overlapping, they will continue their own way. So this is very special for the wave. So superposition is used during this process. So what we have used is when the two waveforms, they occupy the same space during the same time, then you need to superpose them together. And so you will sum them together. So summing here, including subtraction and adding. So you sum them together when they overlap. We'll consider another example in a plane. So this is two-dimensional. So we consider there are two tennis balls. It's in the pond, and they create the ripple. So this is the tennis ball 1, and this is tennis ball 2. So you will hold this two tennis ball, and then you bounce it on the water up and down. You start creating the ripple, and as the waves travel out, this is the ripple. It has the peak. So this, what I draw the circle here is the peak, and this is the peak. So this is the peak. This is the peak here, and in between, this is the valley. This is the valley. This is the valley. Same thing here. This would have the peak, and you have the valley here, and then you have the peak here. So as they approach each other, you will see the constructive interference and also destructive interference. So When we say constructive interference, that's when the peak is meeting the peak. So for example, this is the peak, and that's meeting another peak. So then you will get a double. And or you have a valley meeting a valley. So then you will have a valley, and then you have another valley. And when they meet each other, they will have a double, a 2 times of the amplitude. So these both are constructive. In the destructive case is when you have a peak and then you have a valley. So then they will cancel out and become this. So I'm going to use the solid circle here, solid dots here as the constructive interference. So as you can see, this one here is peak and peak because they're being crossed by the red and the orange. And so that's where this is the wavefront of the peak. And this is also the wavefront of the peak. And then if you look at this location here, you have the peak, and then here you have the valley. So then this triangle here means destructive. So same thing here, if you look at this here, the middle here, this is the valley of this one, and also the valley of this one. So then it's also constructive. And if you look at another example, let's say right here, then you have the valley here, and then you have peak that's going here. So they're meeting peak and valley. So that's the example of a 2-dimensional constructive and destructive interference. So that's what we have today. We're talking about interference using the principle of superposition. Okay. If you're interested, continue watching. Thank you.